Hello friends, this video on Communication Systems Part 18 is brought to you by examfear.com. No more fear from exam. Let us look at problem 1. Digital signals do not provide a continuous set of values, represent values at discrete steps, can utilize binary system, and can utilize decimal as well as binary systems. So you have to tell which of the above statements are true. Okay, so these are some of the options available to you. So the first property, they do not provide a continuous set of values. That is true, right? Because when I talk of digital signals, I talk about signals which only talks in respect of high and low values. That means it either talks about 1 or it talks about 0. So they do not provide a continuous set of values. Very true. Represent values at discrete steps, right? It doesn't talk about continuous values. It says discrete steps. Can utilize binary system, very true. Binary system is nothing but the system of zeros and ones. Can utilize decimal as well as binary system. That's not quite true because it cannot utilize decimal system. It can only utilize binary systems. So which of the option would be true? C. 1, 2 and 3 but not 4, right? Okay, so let us look at the next problem. It says, is it necessary for a transmitting antenna to be at the same height as that of the receiving antenna for line of sight communication? So let us first look at the first part of the question. What do we mean by line of sight communication? Now, line of sight, generally also, what do we mean by line of sight? That means when we look at something, the direction, the line drawn from our eyes to that object, that can be referred to as line of sight. So when I say line of sight communication, that means there is no obstruction between the transmitter and the receiver. So transmitter is there, receiver is there, in between nothing else is there. So that is known as line of sight communication. The question asks, is it necessary that the transmitting antenna and the receiving antenna has to be of the same height if we want line of sight communication? Okay, let us have a look at that. So here in this picture, I have shown a transmitting antenna whose height is represented by HT. And I have also shown a receiving antenna whose height is represented by HR. Now, let us suppose here DT represents the distance of the transmitter from the horizon. Right? Horizon, what is horizon? The place where it seems that the land and the sky, they meet together. So that is known as horizon. So DT is the distance of transmitter from horizon, and DM is the maximum line of sight distance between the transmitter and the receiver. Now, this distance of the transmitter from the horizon is given as root over 2RHT. What is R? R is the radius of the earth. HT is the height of the transmitter. Now, let us suppose that if DM is the distance, maximum line of sight distance between the transmitter and receiver. So this DM is maximum line of sight distance. So this DM will be equal to this distance DT plus this distance as well from the receiver. So this will be equal to root over 2RHT plus root over 2RHR. Now in this problem, it is told that the TV transmitting antenna is 81 meters tall. That means HT is given as 81 meters. Also, we know that radius of the earth R is equal to 6400 kilometers, which is equal to 6.4 into 10 to the power 6 meters. How much surface area can it cover if the receiving antenna is at the ground level? Now, when I measure the height of these antennas, we measure it from the ground. So if I say that the receiving antenna is at the ground level, that means the height of the receiving antenna is equal to 0. So therefore, what would be the maximum line of sight of distance between the receiver and the transmitter. This will be equal to root over 2RHT, because HR is 0, so this term becomes 0. So this will be equal to root over 2 into 6.4 into 10 to the power 6 into 81. So this comes out to be some value which we are not calculating for now. Now we have to calculate how much area can it cover. So now this is the distance between these two. So what would be the area? So the area would be equal to pi r square. So what is r here? R is dm square, because the area which it will cover would be a circular area with this distance as radius. So this will be equal to 3.14 into dm square. So when you square it, you get 2 into 6.4 into 10 to the power 6 into 81. So this is 3255.55 meter square. So it would cover this much of area. So we can say that it is not necessary for a transmitting antenna to be of the same height as that of the receiving antenna for line of sight communication. So what matters for line of sight of communication is that the distance between the two, that is this distance dm. So it is not really needed that both the antennas will have to be of the same height. So let us look at the third problem. It says a carrier wave of peak voltage 12 volts is used to transmit a message signal. So we have a carrier wave whose peak voltage is given. When I talk about the peak voltage, I am basically talking about this value, that is the amplitude. So that means amplitude of the carrier wave is 12 volts. What should be the peak voltage of the modulating signal in order to have a modulation index of 75%? That means AM is something which you have to calculate, and modulation index is given as 75%. Now how do we define modulation index? It is the ratio of the amplitude of the modulating signal to the amplitude of the carrier wave. So from this we can say AM is equal to mu AC, that is equal to 75 by 100 into 12. So this is equal to 9 volts. So this should be the peak voltage of the modulating signal. Simple? Okay. So let's go ahead with problem 4. A modulating signal is a square wave as shown in the figure. The carrier wave is given by this equation. So sketch the amplitude modulated waveform and what is the modulation index. So this is how the modulating signal looks like, and the carrier wave is given by this equation. So what are the values that we can get from whatever is given? So if you look at the equation for the carrier wave, what all information do you get from here? We know that a carrier wave can be represented as AC sine omega c t. Therefore, we can say that amplitude of the carrier wave is equal to 2 volts. We can also say that omega c, that is angular frequency of the carrier wave, is equal to 8 pi radian per second. Similarly, if you look at this sketch of the modulating signal, what all details do you get from here? We can see that AM, that is amplitude of the modulating signal, is equal to 1. This is the maximum amplitude. Okay. What else do we see? What will be omega m? That is angular frequency. Angular frequency is given by 2 pi by time period. So what is the time period here? Time period here is again 1. So one oscillation happens in 1 second. So this is equal to 2 pi radian per second. So from this data, we get a relationship between the carrier wave and the modulating wave. Okay, so now let us see how do we sketch the amplitude modulated waveform. Now, when I want to sketch the amplitude modulated waveform, I'll first sketch the carrier wave. right? Now how is my carrier wave? It is going to be a high frequency wave, somewhat like this, with this amplitude as AC, right? So let me first mark this AC. So what is my AC here? AC is 2 volts. So this will be 2. This will again minus 2. So that is going to be my AC. Now how will this modulate? This will modulate as per the modulating signal. And how is the modulating signal here? Somewhat like this. So this is how the modulation will happen. And a similar modulation will happen in this case also. I'm sorry, I made it incorrectly. It will not be like this, because this will be inverted in this case. So it will be somewhat like this. So this is how the amplitude will be. You remember this was AC and this distance was AM, that is 1, and this distance is 1 here. AM is 1. Now how will be the wave inside? The inside waves will have the same frequency as the carrier wave. Correct? So this is how it is going to be. So somewhat like this. Clear? So this is how we plot amplitude modulated waveform. So for that, it is very important that you have an idea about the amplitude of the carrier wave, the amplitude of the modulating signal. So in that case, you will be able to plot it correctly. Now we also have to calculate the modulation index. Modulation index is the ratio of the amplitude modulated wave to the carrier modulated wave. So that comes out to be 1/2. So this would be the modulation index. Okay. So let us look at the last problem of this lesson. It says, for an amplitude modulated wave, the maximum amplitude is found to be 10 volts, while the minimum amplitude is found to be 2 volts. Determine the modulation index mu. What would be the value of mu if the minimum amplitude is 0 volts? See, so far we only spoke about modulation signal as a ratio of the amplitude of modulating wave to the amplitude of carrier wave. Now let us see if this has a relationship with the maximum and minimum amplitudes of a modulated wave. Like when the wave actually gets modulated, the amplitude varies, right? So there is a maximum amplitude, there is a minimum amplitude. So let us see if this relationship also turns out to be something different. So far we know mu is equal to AM by AC. Now mathematically we can write this as 1/2 AM plus AM. So AM we can write it as half AM plus half AM, right? Similarly, AC we can write it as half AC plus half AC, right? It is all the same thing. We can also write it as half AM plus AM minus half AC minus AC. So what we have done here is basically, here I have subtracted half AC and then I have added half AC. Similarly, below also I am doing the same thing. I am adding half AM and then again I am subtracting half AM. Right? So with this we can say this. So the half will get cancelled in both denominator and numerator. So we get AM plus AM minus AC minus AC divided by AC plus AC plus AM minus AM. So this comes out to be, if we rearrange it, it can be AM plus AC minus AC minus AM divided by AM plus AC plus AC minus AM. Now, if you look at an amplitude modulated wave, how does it look like? So this is AC and this is how it gets modulated, right? And what is this? This distance is AM. So when I talk about the maximum amplitude, what is this maximum amplitude? So A max is AC plus AM. And what is this minimum amplitude? This is AC minus AM. So A minimum is AC minus AM. And right now we want to establish a relationship of this modulation index with this A max and A min. So now we can make use of this. Now instead of AM plus AC, we can write it as A max. And instead of AC minus AM, we can write it as A minimum. So this can be written as A max minus A min divided by A max plus A min. So therefore, we established a relationship, that is modulation index is equal to A max minus A min divided by A max plus A min. So now if you look at this problem, in this problem, maximum amplitude of the modulated wave is given as 10 and minimum amplitude of the modulated wave is given as 2. Therefore, mu will be equal to 10 minus 2 divided by 10 plus 2, which is equal to 8 by 12, that is 0.67. So this would be the modulation index. Now what would happen if A min is equal to, that is the minimum amplitude is equal to 0. In that case, the modulation index will be equal to 10 minus 0 divided by 10 plus 0, that is equal to 1. So this would be the modulation index. So now we have reached the end of the lesson and I hope that this lesson on communication systems would have helped you. Please solve more problems to make your concepts clearer. Thank you. Please visit www.examfear.com to watch more videos, attempt free online test, get free study material, find tutors and mentors. Thank you once again.